Alright guys, this is again Unit 7. Today we're doing Lesson 4. And today we're going to continue our factoring and do factoring based on conjugates. This is a pretty easy factoring technique, and once we get going I think you'll do fine with it. So there's a lot of different factoring techniques, and today we're really going to start looking just at factoring conjugates, binomials. And what those are is a conjugate is just when you switch adding to subtracting between two terms. So this a plus b, its conjugate would be a minus b. You can do the opposite too. The conjugate of a minus b would be a plus b. So what you're going to do is find each of the following products of the conjugate pairs and look for a pattern once you get. So you should easily be able to do a through f. And so multiply those out like you know, and hit pause and only hit play once you have answers. So do that now, please. Okay, so how did you do? For A, hopefully you got down here where it says x squared minus 25. B, x squared minus 4. C would have been 16x squared minus 1. D would have got x squared minus y squared. E was 4x squared minus 9. And F is 25x squared minus 4y squared. Now, did you notice the pattern and how this works out? So you should know that when we multiply binomials, typically we get a trinomial. And hopefully you've learned the pattern by now that when we do these trinomials, we end up adding these two numbers, and that's the middle term. And we end up multiplying those two numbers, and that's the third term. Well, what happens when you have conjugates is when you add these two terms, since they're opposites, these end up canceling out every single time. And you're just left with basically multiplying these two and multiplying those two. And you can see, again, those middle terms keep canceling out because when you add negative 2x and positive 2x, they're going to cancel. So the only thing, again, is doing the x times x and the negative 2 times the 2. So again, hopefully you see that pattern that's working out. If I did this times this, that's where I get here, and 1 times negative 1 is there. And you can again see it through all. These cancel out, and we're doing x times x, y times negative y, cancel out, 2x times 2x, and 3 times negative 3. And it goes all the way through. So really, you could do a shortcut now. When you notice that you have conjugates, all you have to do is multiply the first terms and multiply the second terms, and that's a shortcut you can start doing, which is shown right here. So basically, this is what I just explained. So if you see that you're multiplying conjugates, all you have to do is square the a term, because they're the same. So a squared minus the b squared. That's it. So they want you to use this pattern, this shortcut that we found, to quickly do these problems. So don't do the big work. This is the time where we're saying you don't have to do work, just use your shortcuts. So do that now, please. Hit pause and try them all. All right, for A, how did you do? So you should have just squared the x squared to 6 and ended up with this. Okay. B, 25x squared minus 4. C, 4x squared minus 49 y squared. And make sure you do this in proper order. You can't put the x squared first. Notice the 4 came first, so then the 16 should come first. It's very important. Don't swap those two. Okay, and F. So hopefully that's pretty easy, because once you get that down, we'll be able to do the factoring part. So right now we haven't factored yet. All right, now it's time for us to start doing some factoring. And what we're going to do is we call this factoring of a difference of two squares, a difference of perfect squares. So notice that each of these problems, it's a difference problem because they're subtracting. They're all binomials, so there's 2. And can I take the square root of x squared? You should know this, that the square root of x squared is x, because x times x is x squared. Just like the square root of 9 is 3, because 3 times 3 is 9. So you can take square root of x terms. So if you look at this, this is a perfect square. I can take the square root of x squared. I could take the square root of 81, which is 9. However, I gave you something like this, x squared minus 10. I can take the square root of this, but I can't take the square root of 10. That would give me some type of decimal. So we need to know our perfect squares. So now the way I would show you to do these, well, first of all, you're going to hear this term in the high school a lot. We call this dots factoring. So let's write that down. So dots stands for difference of two squares. So difference of two squares. So your high school teachers will probably mention dots, and you should know what that means. And what I do is just say, can I take the square root of this? Can I take the square root of that? If I can, then I know it's dots. And really what you need to see is it's just a reverse of what we've been doing on these other problems. Notice that these answers here are dots. I could take the square root of x squared and the square root of 36. And how can I factor this in two things that multiply? Well, we're doing the opposite. We're giving you this, and we want you to write it into factors like that. So if you take the square root of each of these, that's what the first terms are, and the second term, and they have to be conjugates, plus and minus. That's it. So this is the way I do it, is I take the square root of x squared is x. The square root of 81 is 9. And now I know they have to be conjugates, so it'd be x plus 9 and x minus 9. And you can see that if I multiplied these using our rule, it would get right back to that right there. So if you want to write that down, you can, but I'm going to erase it in a second and put the official notes in there, but hopefully that made sense. So if you want to pause and write that down off to the side. All right, so this is how they're all written. Basically the same thing. Okay. So all I did again was take the square root of this and the square, we're doing the reverse. Square root of this and square root of that. That's where these numbers are coming from here. Okay? So see if you can do I'll do one more for you. That will help you out. So look, the square root of 9x squared. So that's got two things in there, still monomial. You just take the square root of each part. So the square root of 9 is 3, and the square root of x squared is x. Because think about it, what is 3x times 3x? That would get you 9x squared. So that's the square root. And then the square root of 4 is 2. So now I write conjugates. 3x plus 2 times 3x minus 2. And the plus doesn't have to come first. You can put the minus and then the plus. It doesn't matter as long as one's plus and one's minus. These are exactly the same except just a plus and minus. Okay? So again, if you want to write my sloppy stuff down, you can. I'm going to erase it and put the other neat stuff in there. All right. So go ahead and do the rest of these, and hopefully it makes sense to you now. All right, let's see how you did. So C would turn out to be here. D, E, and F. Yes, 1 is a perfect square. You can take the square root of 1. 1 times 1 is 1. And again, it's very important that a lot of students always want to put the letter first, and they put the Y here. If the 25 comes first, well, the square root of 25 is 5. That should come first there. And don't let these hard ones just like this. The square root of 81y squared is 9y. Okay. So hopefully these answers are making sense. If you're having trouble with this, come see us in class. We'll explain it to you. All right, let's keep going. This one's pretty easy, but just trying to show you how things work. So they have this. Hopefully you notice that that is a dots problem. It's a difference, a subtraction. That's a perfect square, and that's a perfect square, meaning I can take the square root of those. So Amelia believes that the x squared minus 9 can be factored into this, while her friend believes it should be factored into this. So we're going to fill out the table to see which one's correct. So they're saying if x was 0, plug it in for x and tell us what this column would equal. Plug 0 in here, tell us what this would equal. Plug 0 in there. So you should be able to fill out this total table for these input values. So you're inputting x into these different functions and seeing what you get out. So do that now, please. All right. Hopefully on your table you got something like this. So again, if I were to, let's say I'll start with 1 and put it in there, that would be 1 squared, so it would be 1 minus 9, and that's where this is coming from. If I put 1 in here, well, this would be 1 plus 1, so it would be 2. This would be 1 minus 9, so it would be times negative 8, and you can see where the 16 is coming from, and so on. So that's what you were supposed to do, is insert or input these values in. Now with that, you could see that when I input a value in this one and then input the same value into this one, we get the same outputs, meaning these expressions are equal. They don't look the same, but they're equal. Obviously this one is not. So this is the correct factored form, because again, these two are exact same amounts. Another way we could prove it is he wants us to multiply the respective factors to show which one's correct. So here you should be able to multiply this and multiply that. So do that now, please. Hit pause and try those. Alright, for Amelia, you should have gotten this. And again, this is what I mean by you should be catching on to these binomial multiplications. You know you're going to do x times x, and that's the x squared. I can do these in my head now because I know I'm going to end up adding these numbers. See right there. So 1 and negative 9 makes the negative 8. And then I know I'm going to end up multiplying, and 1 times negative 9 is negative 9. So I could skip this step now. I've been doing it so long, and instantly go to the bottom here. Oh, that's not what I wanted. That's what I wanted. So on this one, hopefully you recognize it's conjugate, and I would know, okay, I'm going to multiply those and get x squared. I'm going to add these. Well, negative 3 and positive 3 are 0, and that's going to go away. Then I'm going to multiply those, and I know it's going to be minus 9. So I can do that pretty quickly. And you need to get kind of quick at this too. And there's the answer. All right, that's it, guys. So we'll practice this in class tomorrow, and hopefully you did okay.